Okay, so in this video we want to look at how to build series and parallel circuits using the breadboard. And to start, right, we'll take these resistors out. And I'm using a 200 and a 330, or a 220 and a 330 resistor. And that's what we'll start with, and that's what your procedure will start with, right? But once again, I'm going to start with the jumper cable that goes to the positive terminal and the jumper that will then go to the negative terminal. And I'm going to take my resistors and to put them in series, right? So the top, you just want to pick a row that you're going to go, you're going to jump from the positive toward, and I'm going to put this one toward the top, and I'll show you a close-up of this here when I'm done. The resistors can be just a little finicky. But at the end of the day, it should look something like this, okay? So notice a few things. It might be hard to see, but I will take some pictures with my phone and a little bit more high def, hopefully. But the basic idea is, right, that we've got a resistor running from this row down to this row, and then you want to insert the leg of your second resistor in that same row as the bottom of the first, and then let it run down. And then we're going to put our jumpers from the positive terminal into the same row as the leg of the first resistor. And you want to make sure that you're in the same row. You want to put your second peg in the same row as your first resistor. So you've got that. And then you want to connect your bottom terminal to your second resistor. You want to connect your bottom jumper cable to the same row as the bottom peg of your second resistor, and then jump that to the negative terminal. Right? So now we have a circuit that looks like this. So what's going to happen? Current's going to come in, go through the jumper into the first resistor, through it into the second resistor, and then through the second jumper, and then back out to the batteries. Okay? So I'm going to start out with 2 batteries just because it'll be easier to make multimeter readings. And I'm also going to show you guys how to do this with 1 multimeter for those of you who may not have been able to get the second multimeter yet. Okay, so let's go ahead and connect our terminals. This is the negative terminal, so I'm connecting it to the negative, and the positive terminal will be right here. Now, one of the first things you're going to want to do, all right, and we'll put this in the procedure, is to make voltage measurements across the resistors. So it's a prediction of Ohm's law. Now, I didn't pay too much attention with the size of the resistors and the color coding. It's a little difficult to tell from here. So I'm not sure which one is the 220 and which one is the 330. Okay, but we should have approximately 3 volts coming out of the batteries. And in fact, we can check this real quick. So I'm going to take my multimeter and I'm going to put it on the 20 meter setting, or 20 volt setting, and I'm going to measure the voltage across the leads here. and it's looking like it's about 3.2 volts, right? 3.2 volts. Now, it's a prediction of Ohm's law, okay? It's a prediction of Ohm's law that the voltage should be split amongst the resistors in proportion to their resistance, okay? The voltage should be split in proportion to their resistance. So the higher resistor is going to get a larger fraction of the voltage, of the input voltage here. And so, hopefully you'll be able to see the multimeter here. And I'm going to put my leads across the first resistor. And we get about 220, right? And then across the second one, we get 1. So, the first resistor is drawing 2.2 volts. The second resistor is drawing 1, or I shouldn't say drawing. The first resistor has a voltage of 2.2 volts, and the second resistor has a voltage of 1 volt. Okay. Now, how to measure the current? Okay, so remember, in a series circuit, the current should be the same everywhere. Now, I'm not going to go through the steps to prove that to you, okay? But if you are so inclined, you can do it several different ways. You can take out this end of this jumper and this end of this resistor and measure the current through those two parts. We're going to take out the center pegs of the resistors and clamp our ammeter across those. All right. Whoops. Okay, so we've got those clamped, and I'm going to remove. Now, okay, you can touch this circuit with impunity even though current is running through it, because there's only 3 volts running through here. And even if you had all of your batteries lined up, and you're going to start with 1 battery and then work your way up to all of the 8 batteries. But even if we had all of them, 12 volts is simply not enough, especially with DC direct current, to do anything to the human body. So you can touch this with impunity. The one caveat to that is when we get to capacitors, we'll show you how to discharge capacitors properly. But for the moment, all right, so now what we want to do is we'll clamp our positive terminal on our ammeter to the first resistor here, and then we'll clamp our second, and now I want to adjust my multimeter to amperage, okay, and I've set it on the 20 milliamp setting, okay, and as you can see, it's drawing 9.72 milliamps, okay, 9.72 milliamps. If I put it on the 200 milliamp setting, then I don't get as precise a reading. So for this measurement, I want to keep it on the 20 milliamp setting, and 9.73 milliamps. So that gives you the way to measure the amperage and the voltage across your system. All right, that gives you the way to measure the amperage and the voltage across your system. One thing you can do in a series circuit, and this may be advantageous for you if you don't want to keep connecting and disconnecting your resistors to get voltage and current measurements, because you're going to make several different measurements with your batteries. And so one thing that you may want to do, all right, is leave your resistors alone. And you can do this. You can leave your resistors alone. And what you can do is add an extra jumper. Now this will look a little more messy, but you can add an extra jumper. All right. You can add an extra jumper. You can pull this one out and add an extra jumper here. Put that jumper where the old one went in, right? And now you can just measure the current across these two wires, these two leads, right? So connecting and disconnecting these might be a little bit easier than constantly connecting and disconnecting your actual resistors. So if I put these across here, you'll note that we get 9.72, all right? So this is resistors in series, and what you're going to do is, once again, prove both Ohm's law and the prediction that when you have resistors in series, they will add their resistances, okay? Now, so this is what you're going to do for the series case, and then you're going to keep adding batteries and batteries and batteries. And when you need to measure your voltage, okay, if you use this method with your two jumpers here, to measure voltage, you do need to disconnect one and complete the circuit to measure your voltages, because if you have a gap in your circuit, then there's no current going to be flowing. You're not going to measure any voltage. So, but it might be a little bit easier just to keep connecting and disconnecting a single jumper like that to measure your voltages, and then to insert another jumper to measure your currents. If you use if you have two multimeters, then what you can do is just leave your circuit like this and leave the current multimeter in the circuit, and then as you add batteries, it'll just automatically read off the new voltage or a new amperage, and then just place your leads on your voltmeter, the multimeter you're using to measure voltage, across each resistor in turn. But if you only have one multimeter, then this is probably your best solution right here, is to use these two jumpers to measure current and then to measure voltage. Just make sure you have the circuit complete. Okay, so there is your series case. Now you're also going to use a few different values of resistors, but I'm only showing you the first values that you'll use just to show you how to do it. Once you have the other ones, the setup is exactly the same. So now how do you build your parallel circuit? Okay, so let's build a parallel circuit, and we'll build this one from the ground up, and we'll disconnect these. So we'll leave our power jumpers in, and to build a parallel circuit, what you want to do is you want to have your resistors in the same rows. So if my first resistor I have in this row, then my second resistor, I want it to be in the exact same rows. So it would look something like this. Okay? So now my resistors have the pegs in the same rows, and now my jumper needs to go from that same row, another peg in that same row, to the output, right? And so we'll show you the circuit here. All right, and once again, we will connect our Now, this time, both resistors should have the same voltage, so you might need to kind of, move them out of the way from each other. But now I'm going to put my meter back on voltage, okay? And it's almost easier to measure voltage with these probes without the clamps on. And so to measure voltage in the parallel case, now I'm going to take my leads on my probes and I'm going to put them across the first resistor, and we're not getting any, we're not getting a reading because I'm not jumping from the power to that row. I need this jumper here. There. All right, so now when I put across, I'm getting 3.16 for the first and 3.16 for the second. It's bouncing around just a little bit, but the tighter you can make your connection, the better. So now to record your currents, okay, I'm going to reclamp those. And I'm just going to go ahead. Oh, no, I can't use that end. I don't want to take that off. I'm going to take that edge out and put an edge in here. Now, this measurement is going to measure the current in the total circuit, okay? This measurement's going to measure the total current in the circuit. And the theory of series and parallel says that the current should increase when your resistors are in parallel. So that's why I've set it to the 200 milliamp setting, okay? And you should be able to predict what the current ought to be. And I'm going to clamp that lead there. And I'm going to clamp this lead here. And I get 44.7 milliamps. Okay? 44.7 milliamps. If I adjust that down, that's too much. So 44.98 bounces around just a little bit. But to within, a tenth of a milliamp, it should be pretty consistent, right? And you should be able to predict using Ohm's law and the rules of series and parallel circuits you should be able to predict what that value ought to be. So then you can compare your actual measurement to the prediction, okay? But that's how to set the circuit up. All right, that is how to set the circuit up. So, hopefully, you have found this useful. And if you guys have any questions, feel free to ask. And we will talk to you in the next video when we talk about Kirchhoff's rules. All right? Take care, everybody.